Okay. Omer, ready?
I'm very much ready. I have props today and action. Bam.
Wow.
Yes.
Props, Shazam. Ready. Action, action, action.
Let's go.
Let's go. So, hello everyone, and welcome to the Omer. Are you ready for it for the 17th? This time I
17th.
remembered.
Yes.
17th, yeah, episode of DevOps Topics. And today we are going to talk about containers.
Containers. We just need to add something. We have discussed containers in the past as if everyone knows what it is and how it works because we assume stuff. And we did start with container orchestration, which was probably premature. So today we're going back to the basics and talking about containers from the ground up.
And maybe also about CI/CD. Maybe,
Maybe. We'll
maybe.
see.
If we know what is CI/CD. Yeah,
Yeah.
we'll see. Okay, so Omer, what's the first thing that comes up to your mind when I say containers or Docker?
Okay. Let's start with what you said, or Docker. I think that's not a synonym, and we need to get used to in 2023 not to say Docker containers. We need to say just containers, container images, stuff like that. One, because Docker is kind of, it's not dying, but it's kind of a lot of its place is taken by other providers. We'll touch on them a little bit later, but it's not only Docker today. There are a lot of new players in this ground. So first of all, not Docker containers. For me, at least, you can say Docker. That's fine. And the first thing you asked me, what's the first thing that comes up to my mind? And that's kind of an unfair question to the crowd, because when you ask me what's a container, I had to, like, first of all, learn on my own what containers are, then teach others, then read about it. And obviously we work with it daily, both of us, and I'm assuming other engineers that are listening in. So let's just give 2 sentences of a basic background for those of us who are not completely familiar with containers. And then we'll move on. But you need to approve my words.
Approve.
So
even before you said it. Approve.
Oh, come on. I'll tell you how I introduce it to people that don't know it at all. So what we have used to, we got used to working with servers in the past, right? We had physical servers. Today a lot of companies are working with physical servers. A lot of others are working in the cloud. But we were used to physical servers regardless of how we work with them. And then there was this notion of virtual machines, which were kind of a way to compartmentalize different components of the server and basically utilize the same amount of resources. For example, I have a huge monster of a machine with 8 cores and a lot of memory, and I can utilize it for a lot of applications rather than running one process. And then some people might say, okay, just run a few processes. What's the problem? But then I tell you, what if I'm running one process that's a Python application or a Django application, and the other is Ruby on Rails. The third one is a Postgres database, and the fourth one is an Nginx process, right? At some point, we'll have a lot of issues, conflicts, stuff are going to happen because I'm installing many dependencies with many package managers. Even if I'm just using one technology, if I'm just running Python, maybe one is running with 3.7, the other is 3.5 or 2.7. This creates a lot of issues in the computing world.
And so, I'm just, I'm gonna stop you for a second. I mean, we skipped the part where you just said compartmentalized, and it was like amazing. So I had to. Okay, so all the time you talked, I was like, you said compartmentalized, like. Okay, good for you with that word.
One of my hobbies is learning new words and just injecting them as if I was born with that.
Like priority.
Exactly. Prioritization.
No.
Proprietary. Yes.
This one.
You're
exactly.
Right.
Okay, so just even before you go ahead with the Python 3.7, 3.9, whatever. So I think let's focus on the compartmentalized that you said.
Okay. So again, the idea here, and I'm not yet touching containers. The idea with virtual machines was let's compartmentalize. Let's separate the resources, right? Because I can use the same core, I can use the same amount of resources, but I'm having some kind of separation. And the idea of separation is having a clean environment. Because if I run now pip install and I'm downloading stuff from the internet, the environment is clean. Now, there are ways to fix that with tooling. For example, for Python, you have pyenv. For other applications, you have similar tooling. It gets complicated. You can imagine not all technologies have the same way to separate environments, and having a virtual machine is basically your way of taking one large box and separating into small boxes and installing many, many boxes. When you explain to someone that's not even part of our field, you can say that I have a huge box with a lot of resources, there is a lot of space. Instead of running one tiny box in it, I can fit as many boxes as I can, and that way I utilize and obviously save money, obviously whatever are the byproducts of utilizing a resource. And then someone said, okay, virtual machines are great, but it's kind of like duplicating the same operating system again and again, not going into the intricacies, another great word, intricacies, not going into the specifics of what does that mean to replicate the operating system, but operating system is something that's heavy to replicate. It takes a lot of more resources, again, because the separation isn't free, okay? It costs a little bit. So let's use containers. Containers is a way of, by the way, built on Linux. In Linux, it's called namespaces. I think it's based on that, right? So you have namespaces in Linux that let you kind of separate different resources, CPU, memory. You can allocate different parts of your resources on the machine to different processes and create a complete separation between them. So containers are built on top of that. I think the term in Linux is C groups. So that's based on that. And C groups, that's the base of containers, essentially. And then you have a complete separate environment with its own operating system, but it's utilizing the underlying machine operating system. I hope this makes sense, but let's just say at that, it's a lot more efficient way to run small boxes inside this big box. How's that for an explanation, Meir? Can you rate me 1 to 10?
10, always. It's always 10. I'll just add that
Okay.
You said Linux, but it's also relevant to Windows, right? Because you also have Windows containers.
Well, hopefully not, but yes, you're very much
No.
right.
But you do.
Right.
You have Windows containers, and I think like what I like to do with Windows containers, like if you are creating an installer maybe for your Windows application, so if you do it inside a Windows container, it's easier. Not sure if we'll get to that, but just viewers, listeners, keep that in mind.
Something that's important here. When you're running stuff that are not as in when you're running containers not on Linux, I think you need to have a special hypervisor, and that's kind of a layer between the underlying operating system. In this case, not Linux, can be Mac OS, can be Windows, whatever you're running there. But this would create some kind of translation for the system to be able to actually utilize containers. It's not available for you like you would have with Linux. That's one thing.
So either way, so I think we can say that for local development, usually, I would just say usually, I hope I'm not hurting any developers who work on Linux, okay? But usually we work on Windows or Mac OS, right? So for local development, you usually have a hypervisor, as you just mentioned.
Yes.
But in the cloud, where you run stuff, on Kubernetes and whatever, then over there, like there's no hypervisor, so everything is super fast as it should be. So for local development,
it runs natively, basically. Yes, when you're running on Kubernetes in the cloud, it's pretty much native. Yes.
And performance-wise, it's especially file system when it comes to file system regarding the copy files, move files, write files, read files, whatever. So that's very important to work as native as you can, because if you have high loads with I/O, input, output, throughput, then it may take a lot of time.
I want to stop you there for a second, because I feel like you jumped a little bit forward, because we both kind of well versed in the field of containers. But you said you started with local development, right? And I want to make an argument, and I want to hear your opinion on that. And I always argued to developers that you need to kind of know containers. It used to be only Docker, but you need to know Docker. You need to know how to work with with containers, even if you're not running literal containers in the cloud, or that's the end goal of the day, just because its ability to separate you from the environment. And then I heard stuff like, no man, I have pyenv, I solve it with this and that and that. I believe that having a container that installs only what you need with the exact same environment that you'd be running, even if that's a machine, right? An EC2 on AWS. It's not a container, nothing to do with containers. You'll still get a lot of benefit from that. What are your thoughts on that?
So I can tell you that in the past few days, recently, I think that will be like jumping to the end of the conversation, like this, my story of the week. that I created like this full monorepo for front end, back end, and database and everything all together, right? And as part of it, I thought to myself, should the local development process be in containers, or maybe install the applications natively and locally on the machine? So just to give you an example, just a glance of what application I'm talking about. So let's say Node, right? So as you said, if you have multiple versions of nodes, you can use NVM, right? Node version manager. Same for Python, Pyen, whatever.
Same for Ruby, RVM, yes.
Yeah, so to tell you the truth, because I like all the functionality of hot reload when it natively runs on your computer, and for local development, like to me, like fast is top priority. If it's not fast, it's not good, because I want the fastest input I can get. Input, output, whatever you call it,
Agreed.
So when it comes to combining containers, so the only thing that I run in containers is, I'd say database or local, okay, for local development. So database, AWS Cognito. So for example, local stack, if you want local authentication and everything.
Great example.
So I'd say external services that I'm not building, I will run locally as containers with Docker Compose, right? But the things that I develop, like Nest.js backend and a frontend maybe with Vite or React, whatever.
Right.
So these ones I'm not running in containers. These ones are running natively on the machine.
Perfect. Why?
What? Now you're going to cry. Are you ready for the why?
I'm not sure. Am I?
Because the docs, okay? I always say read the docs, right?
Okay.
If the docs were oriented for development in containers, I'd go for that. But because all the docs for all languages are oriented for please install this on your machine, I'm like, if I want the developers to be aware, and because sometimes what I do, I create something or work with the developers, and I want them to have the docs of open source projects that we're working on without maintaining a new set of docs and whatever. I want it to be as aligned as possible with the, let's say, Nest.js, okay? I don't want to rewrite the docs just to work in containers. And I don't want them to tell, oh, read this blog post, you'll learn how. No, read the docs of Nest.js. It's exactly what we need to do in our project. That's my answer.
Good. Okay, so it brings me to my next idea.
Like a developer, right?
So no, actually. So that is exactly what any developer would say. I've been working with Nest specifically for 1.5 years, and I did run it in a container, but maybe that's because my thinking is I'm more oriented with ops, at least in some parts of my career, let's call it. And I know what's going to happen, what issues I'm going to tackle. I'm not at least when I was working on that, my thinking wasn't exactly a 100% developer. It was someone that thinks this has to run in production. I very much cared about it. And I 50% of me wanted it to run smooth and fast, like you just mentioned, working exactly like the docs suggest. But the other half of me wanted to see this running as it would on Kubernetes, or in my case, I don't remember even what it was, but it was running on a container. I wanted to see the end result in my face, right? And I wanted to work kind of in tandem because I want to have the thing running in front of me in a container. I still wanted to have my nice environment. I love Vim. I want to develop in Vim. I don't want to SSH into an instance and do something like that. You love Vim? Let's talk about it on another episode because I can have a podcast just on that. Okay. So what I do, and I'm assuming you're too, with local development is basically I am using Docker Compose just like you because Compose is awesome. I have a comment on Compose. Remember, I need to say something about that, but that's at the end. So I'm using Docker Compose because it's easy to orchestrate stuff, exactly like you said. You can use services, MySQL, Postgres, whatever you want to put there, and have a direct link between the containers. And obviously, instantly, if your container crashes, it'll put it back up. You can scale things up. You can do lots of nice stuff with it. And I just mount my local directory onto the container so that I can keep working on files. And basically mounting, for those of you who are unfamiliar, is literally mounting your local development workspace onto the container. So the files you're changing are not copied onto the container, it's the same file. Okay, your container sees what you're doing locally. And then when I change, you're speaking about hot reload. So I'm changing the code, I'm saving it in Vim, and the hot reload does its thing and it reruns in the container. That's why I like it, and that's how I like to work. That said, I totally get what you're saying. So I'm just putting it out.
But I have a hybrid solution of what you said.
Go ahead.
So, because I don't want the developers to upload their code to the cloud and then everything would explode, because we like explosions, but not when it comes to the cloud, right? The cloud should be calm, right? Everything should be in place. So what I do usually, as I told you, I use like in previous sessions, episodes, I told you I use a make file. So everything is aligned with the developers and CI/CD and whatever. So as part of my make file, I love to add a command like make, like a make run production maybe.
Right.
And then so I also add, so let's say that it's like a front-end application. Usually you build it, right? And then you have static files and it's in the dist folder, okay?
Yes.
This directory, dist folder. And then I add another layer, okay? It's like an external layer, like maybe a server layer, okay? Which imitates, I'd say maybe like AWS CloudFront or Cloudflare or anything that serves my static files, just to allow the developer to see how it will look like if they upload everything to the cloud. So then, like the application, even though they develop everything with the hot reload, the Nest.js, which is a backend, and the front end, which is React with Vite or whatever, I enable them the ability to just run and test, because they don't do it all day long. But if before they upload, before maybe they commit and push, maybe before a big change, like it's not really a test. It's more of this is how it's really gonna be in the cloud. You know what I mean?
It does. What physically when you run make production? What's
containers? So it's gonna take the file. Yeah, it's gonna build a container exactly. So it's gonna run a container out of it, as you said, like mount the code. It's gonna do what you said, but not as part of the development process. But as I said, like a hybrid solution of they're working with a hot reload locally, natively, everything is super fast, and still, they can check if everything works if they upload it to the cloud. So that's my hybrid solution for that.
That's perfect. That works great. And that exactly connects to the part that I want to know that it works, because it'll have to build the code. If you're running, I don't know, you're running Nest, you're probably working in TypeScript, I'm guessing. You have to transpile your...
Happened to me now with React. Everything worked when I wrote down Vite dev. Everything worked. And then I was like, okay, Vite build, boom, crashes. Why? React 17, React 18. This doesn't support. This does support. Blah, blah, blah.
Perfect.
It got crazy.
Here's a great use case, another great use case for containers. Should we take it to the next level and speak about the cloud?
Go and speak about the cloud. We have enough time to speak about the cloud.
Okay,
5 minutes or so.
It's not really
cloud in 5 minutes.
Okay, what I meant to say was I want to talk about production. So far, we've been talking about containers for local development, which is amazing. I like it. Here you are liking it too. So the real use case for that is putting things in production. Pretty much for the same reasons, by the way. You want to have an environment that's easy to replicate. You want to know that what you're doing locally can be replicated in production. And you know how the title goes? It works on my machine. We get rid of that. I don't care that it works on your machine because I don't know what your machine is like. I don't know what versioning you have, what packages are installed, what versions you're not even aware that are installed, what other surrounding, surrounding services are running in the background and I'm not aware of. With containers, it just won't work.
I like to aggregate everything you said. Like when I solve problems, I say, what's the state of your machine? It's like saying, like, if I take everything you just said, I'd say, I don't care about the state of your machine, which includes everything you just said, So it eliminates the state. This is what I like about it. Let's eliminate the state.
Exactly.
And then we get stuck with the versions. You know what I mean? So let's make sure the versions are right. But if you have the state, eliminating the state, I think that's most of the time, it's like 90% of the problem, I think. To me, I think most of the time it's like, oh, I also installed this and that on my machine, and it conflicts with this one because it's installed globally, and
exactly. And that takes me to the next thing that we haven't touched yet, and that's the Docker file. And Docker file is your way of seeing exactly what you said as code, because we have this way of templating what you just said, the versions, the operating system, the underlying layers, the environmental variables, whatever else, the arguments, processes, everything. It's just listed in this template that's called the Docker file, and you see what's going on. Yes, there is a way to snapshot containers without seeing all that, kind of like taking an AMI for an EC2 and AWS. You can just Docker commit, and then you have a snapshot works pretty much the same, not the common use case. You'd more often than not, you'd want to have a Docker files. I think we can have a full episode just on Docker files and best practices and how to work with them. Up to you if you want to leave it as that or get further into it. I just want to finish the idea of production. So we talked about the ability to replicate your environment from local environment to the cloud or wherever you're running production. So that's one. The second thing is we want to scale. We talked about scale in the past. We had one episode speaking exactly about that. And containers lets us scale. I talked about virtual machines before. That also allowed us to scale. With containers, it's much faster because we're sharing the host. We're sharing the operating system of the host. So it's easy to replicate the containers, especially if they're small, if they're efficient. It's easy to just put up more of the same. And then I can run a lot of instances. And this means I can scale up. I can obviously share the load, probably use some kind of load balancer on top to help me with the routing. And that's why containers are great. And if I'm taking it to the last level, we talked about replication, we talked about speed of instantiation. And the last level is obviously things like ECS, Nomad, Kubernetes. We have in the world orchestrators. And these help us to have a fleet of instances of nodes that are serving as daemons. We don't have to manage them. They're managed by the cluster. And then I can take a lot of these small boxes that are called containers, just spread them around on the instances, and that's taken care of by the cluster.
But we have to do this, you have to do this to orchestrate between them, It's got to be like this, because you orchestrate between the containers.
You're here for the effects.
Okay.
Yeah. That's it.
Okay. I say about educating for containers. Okay. So for example, the research team in my company, they're like, okay, so they need to install many applications, many Python applications, switch between Python applications. And I didn't know that. So then I asked them, like, what are your problems? Like, what delays your delivery and whatever. And then it felt like if they just use containers, maybe creating a Docker file with Docker image, version all their applications in one piece, they can just run containers, run the application in containers, like the ones that they can. It's important to say, we talked about containers, but if you need a graphical user interface, forget about it. Okay, and some applications need graphical user interface, especially if it's research. Maybe it's something like OpenCV, that requires face detection. I don't know, like many applications need graphical user interface. So as long as you don't need graphical user interface, maybe even your research team or development team or QA team, if you want to aggregate or, to couple a set of applications together without breaking stuff, and then, as you mentioned earlier, like it works on my machine, why doesn't it work on your machine? Exactly. So then they can talk in Docker images versions, like, have you taken this image or that image? Which image version are you working on? Instead of talking about Python version, application version, blah, 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 blah. So maybe education to containers is also a good thing, not only in R&D, maybe even for sales if they use applications. I'm not sure, like anywhere in the organization.
So you reminded me of a very important tip about containers running in production. You talked about how we can pinpoint one specific version of a container. When we build containers, we give them something that's called a label. They give themselves this kind of a hash, kind of like a Git hash. When you push them into what we call a registry that hosts them, can be for production or not, we're naturally giving them some more human readable labels, let's call them. This is for production, this is staging, this is for this branch, this is for
your favorite one is latest.
Oh, okay. This is it. Latest is a bad label to use for everything. Not only for containers, but operating systems, versions of libraries. I'm pretty sure that everyone listening into this already knows that. And if you don't, please do listen to that carefully.
Latest is not the greatest.
Let's leave it at that. I think we're done. Basically, latest will ruin your life at some point. It'll be great as long as you go. Automatic updates, funny stuff. At some point, you'll break something. That's because you're pulling latest. You have breaking changes. You're not aware of what's going on. And the next thing I wanted to say, which builds on top of that, is if you keep pushing latest and get rid of all the other labels, it'll be hard to pinpoint a specific image. You want unique, unique one-to-one unique labels, so you can pinpoint something, and when you go to production, you know exactly what's running, and you can pinpoint the hash and maybe even debug it later locally if you want to do stuff. That's it.
You know that if you use latest, like let's say you do like
You
to
go
use
to hell,
latest, okay?
right? That's what you wanted to say?
And except for going to hell,
Yeah.
you can, okay, you can use the hash digest to pinpoint latest. Did you know that? So if you have a tag, okay, tags, just to be, we are aligned, okay? Okay, guys, okay, girls. Tags, Docker tags, I mean, container tags are mutable. It means if I tag something as version 1.67, whatever, it's still mutable. It means that if I push the same tag again and something's changed, the tag will be updated. So it's mutable, it's editable. But the hash is immutable. Okay, the SHA 256, digest, whatever.
Yeah.
So you can use latest all the time. If you want to use a fixed version, like the same version all the time, you can add the @ and then add the hash. So it can be like latest, @ hash, whatever, like with the
I did
SHA
not know
digest.
that.
Yeah, so that's very cool. So, okay, why am I saying that? Because if you want to use an open source project, and they don't have other tags, so an open source project in Docker Hub, and you're saying, listen, they have the latest tag now, but maybe a new version, will update the tag of latest, and it will break my application. But I still want to use this specific latest version. So how can I pinpoint that? So you can use SHA digest with the latest, and then you can pinpoint latest to a specific version. Cool,
Okay,
huh?
that's a perfect tip. I think it's hard to understand from the audio, so let's put that in the show notes if you're really interested to understand it, because I know I am, and that's a really cool tip and will be helpful for a lot, for sure.
Okay.
All right. Do you want to wrap it up? What do you say?
I think I already said my experience of the week with the Nest.js and the React, whatever. But even though, we say even though, not though, even though, okay? Because we like dough. We like to eat pizza, so we make dough. Yeah.
Some of us.
So yeah, some of us. Even though we are ending this conversation in a minute, we need to ask Omer, Omer, what was your experience this week? Project, something funny, anything.
Okay.
Tool.
I do have one, but I will take one step back on myself saying we need to wrap it up. And I just want to say one thing. We talked about Docker Compose. So I
wanted to remind you that. Yeah, okay, good.
Okay,
Compose.
I have one comment on that. I've uploaded like a YouTube explaining the basics of Docker Compose, and a guy from Docker reached out and told me, everything's great, you're working really nicely. I was actually testing a local development, trying to show people how to work with exactly what you said, mounting my local host, using services like Postgres, etc. And he told me, that's all nice and dandy. You know how you run Docker-compose?
It's Docker space compose.
Exactly. Docker-compose is a Python version, not supported anymore. They're getting rid of it. The new version, Docker space compose, is written in Go. That's the one that Docker is supporting. General public information. That is it. That was my comment about my cool project. I have a lot of them. I'll pick one. You probably already know my love for NeoVim and Vim. And we were discussing at my company this week what tools we can use to collaborate. Collaborate in code, we're actually looking for ways to have a per programming session. Pretty easy in VS Code, not very easy actually, but you can do it in VS Code. We talked about a new IDE, I forgot its name. It's a new startup. They're developing an IDE that's centered around running per programming sessions. It's easy to share your screen, easy to see double cursors, easy to edit different stuff. You can know who's doing what, kind of like working on a shared Google Doc, but with code. So there is a plugin. We found a plugin for NeoVim that's called instant.nvim. I'll share it in the show notes as well if you're interested. And that's basically letting you do the same. You're starting a session. You get like this SSH hash and secret, of course, to let your partner connect to your local machine. And then you get a split screen. It shows you who's doing what. It shows you the name next to the code that's written. You can see double cursors starting to run and typing stuff. There's a really cool demo on their GitHub page, so I'll put it below, and that's it. That's my finding this week. So I'm excited to try it next week.
Yalla, cool.
All right.
Exciting.
Yes.
Okay.
Anything else?
So, I don't think so. We had enough fun for today, I think.
I think we did.
Okay, so see you next week. This time we will see you next week.
Thank you for the crowd. Yeah? Thank you for everyone attending.
Thank you, crowd. Yeah.
All right.
Bye.
Bye bye.